Yo. What's up? Good morning, good afternoon, good night, whatever it is. Some of you guys watch this stuff so late, it's ridiculous. I can see the tags on this stuff, like little timestamps you put on it. Dawson was watching this at 4 a.m. or something like that. Anyways, it's crazy. Y'all should try sleeping. You're like cats. You're up all night and sleeping all day. Anyways, here we go. Find the reference angle. That is the last target of lesson 4.4. And a reference angle basically has two purposes. Number one, its purpose is for you to find the value of the trigonometric ratios with very large angles, like the sine of 538 degrees, stuff like that. And the second thing is you need to understand a reference angle to understand what the calculator is returning when you're finding angles. I'll talk about both. So let's start with this. First of all, a definition. Let theta be an angle in standard position. Okay. The reference angle is defined as the acute angle theta prime formed by the terminal side of theta and the horizontal axis, aka the x-axis. It's actually very simple. So let me give you two examples. Example one, find the reference angle of a negative 330 degree angle and then evaluate its sine, cosine, and tangent. So if I asked you at the top of your head, what is the sine of negative 330? You'd be like, oh, I don't know. But if you draw the picture and find the reference angle, it's actually very easy. So let's do this negative 330. Let's see what we get. So I'm going to start here and I'm going to go, that's negative 90, negative 180, negative 270, and that's going to be about negative 330 degrees. So I'm going to draw that angle right there. So there is the terminal side of the angle. And this will be my angle theta, and that is going to be 330 degrees. That's my angle theta. Ooh, excuse me, negative 330. So let's read the definition again. The reference angle is the acute angle formed by the terminal side of theta and the axis, the x-axis. So here's a terminal side, here's the x-axis. Therefore, the reference angle must be this one here. And I'm going to call that theta prime. So the reference angle of an angle that's negative 330 degrees is actually a 30-degree angle. So that's all it is. See, it's very simple. I told you it was simple. The reference angle is basically the acute angle formed by the terminal side and the x-axis. And it allows us to find the sine, cosine, and tangent easily. Because you know that the sine of 30 degrees is going to be 1/2, then you know that the sine of negative 330 must also be 1/2. That's it. Yeah, I know that wasn't hard, was it? Now, there's one more little detail that you are going to see in the second example, but we'll get to that in just a second. Oh, the tangent. So these first two I'm getting straight from the unit circle. The tangent, unless you have it memorized, you might need to figure it out. So you could say, well, the tangent is the sine over the cosine. So it's going to be 1/2 divided by the cosine, which is times 2 over root 3. Those cross out, so the tangent is 1 over root 3. Or if you'd prefer, and most, wait a minute, what am I doing? I did something icky there. Multiply top and bottom by root 3, and you get root 3 over 3. I think Webestein actually takes both of them. However, classically, in mathematics, usually we rationalize the denominator for a final answer. Okay, so that's what a reference angle is. Let's do another example, though, where finding the trigonometric ratios is going to be a little bit trickier because there's one more little thing you have to consider. So here we go. Find the reference angle of an angle that is 10 pi over 3 radians, and then evaluate the sine, tangent, and cosine. So over here, I kind of broke it down. So 10 thirds is obviously 3 1/3. And 3 1/3 pi means pi plus pi plus pi plus pi over 3. So that's my angle. I kind of broke it down to think, well, how big is this angle? Now it's going in a positive direction. So it's going this way. So here is pi radians, half a turn. Here's another pi, another half turn. Here's my third pi, another half turn. And then a third of pi, so about a third of the way. And it's going to be about right there. So this angle is really, really long. It's over 2.5 turns. And it looks like that. Really long, I mean, really big. All right, so there's my angle. It's a really ugly guy, and that is my angle theta. and that is 10 pi over 3 radians. All right, let's read the definition of a reference angle. A reference angle is the acute angle, theta, formed by the terminal side theta and the horizontal axis. So now the horizontal axis is here. It's still your x-axis, and my terminal side is there. Therefore, my reference angle is this guy right here. He's my theta prime. He is the angle formed by the terminal side and the x-axis. So how much is that terminal side? Well, you can kind of tell by the way we drew it, because this distance here obviously was this pi over 3. So my terminal side is actually pi over 3, a third of pi, also known as 60 degrees if you like degrees more. But you need to start getting rid of the degrees. So now I'm going to find the, well, let's see what I actually want to do. I'm actually looking for the sine of theta. So I'm going to look for the sine of theta. That's what the question was asking you to do. So what I'm going to do is I'm going to use the terminal side. And basically, this is pi over 3, or 60 degrees. So I'm going to look at my unit circle, and I'm going to say, okay, what is the sine of pi over 3? And I'm getting root 3 over 2. And I look at the unit circle, and I say, what's the cosine of pi over 3? And I'm getting 1/2. And then I'm asking myself, what's the tangent? Well, the tangent is the sine over the cosine. And I'll show my work again so you guys can see how I'm getting this. So the sine is just going to be that, and I'm going to divide it by 1/2, which is multiplying by 2. And so my tangent is going to be root 3. Okay. However, now there's one more thing you have to consider. So we got the absolute value of the values of those, but there's one little thing you need to consider. You guys remember that all students take calculus? In other words, in the first quadrant, all of the ratios are always positive. And my first example was in the first quadrant, so everything was positive. I didn't have to think of anything. But in the third quadrant, you see how it says here that the tangent has to be negative? So you're going to have to think about that. Excuse me, tangent's negative. The tangent's positive, my bad, and everything else is negative. So you have to consider that. Remember that in the third quadrant, the sine is going to be negative, the cosine is going to be negative, and therefore the tangent, which is a negative divided by negative here, is going to be a positive. By the way, I don't know if I mentioned this before, but the tangent is actually the slope of the terminal side. Always. The tangent is always the slope of the terminal side. And if you think about it, it's quite obvious why. Because remember, the tangent is defined as opposite over adjacent. And look at this. What is the opposite over adjacent? Isn't the opposite over adjacent simply rise over run? Look at it. Opposite over adjacent is rise over run. So because the opposite over the adjacent is actually the rise over the run, your tangent is going to be the slope of the terminal side, which tells you intuitively that if the tangent is in the third quadrant and if the line's going up this way, it has a positive slope. So the tangent has to be positive in the first and third quadrants. But if it's going like this, the tangent's going to be negative because it has a negative slope. Boy, I sure made an ugly mess out of that. But anyways, it's a nice thing to remember that the tangent is actually the slope of that terminal side. And the slope here is obviously positive. You learned that back in Algebra 1. All right, there's one more thing that you need to understand regarding reference angles, and that's this idea. If I punch into my calculator in degrees, the sine of 30, it's going to give me 1/2, right? And if I then punch into my calculator the inverse sine of 1/2, it's then going to give me 30 degrees. And so you guys are like, oh, thank you, Mr. Peretti. That's deep. Now, what happens if I punch in the sine of 150 degrees? What do I get? Well, I also get 1/2. But now think about this, folks. What happens if then I take this 1/2 and I punch it in and find the inverse sine? Is it going to give me 150 again? No, it's just going to give me 30. Okay? So what you need to understand is that when you're finding an angle in your calculator, it's only going to give you basically the reference angle. So if you want an angle that's actually like 10 pi over 3 radians, you're going to have to think and adapt. The calculator is never going to give you 10 pi over 3, or it's never going to return a value that's more than 90 degrees. So that is something that you're going to have to then make that leap and think, okay, what is the situation here? So reference angles have two things. They allow you to find the angle of large angles, like I showed you here. And the second thing is you need to just be aware that your calculator, when it gives you an angle, it's actually basically giving you a reference angle. Okay? I'm going to leave it right there for now. So next time we're going to have some more fun, but that's it for today. And this week you also have a little quiz / test / assessment to do. Do a good job and come to the meets. That way you can extra practice. Learn as much as you can, guys. This is your free education and you only get one shot at it. As soon as you're done with high school, you're going to have to pay a lot of money for it. So enjoy your free education. See you next time.